Hello. Today, or better say yesterday, because it is already the next day, I participated in Universal Cup Stage 27, India. Uh, by the way, it was hugely disliked, but actually I liked it. So I don't see a reason why to dislike it. So the reason why I disliked it, yeah, I did it, and you can see it here, just because, well, I didn't like some of my verdicts. So I got the first verdict during the contest was wrong answer here. That was because I considered some case incorrectly. This was sad. Because of that, I lost first solve for this problem. Yeah, 33 minutes, and some other team solved in 31 minutes. However, the contest was nice, definitely. The contest, I liked it. It featured different ideas, various. So, if the author of the rounds watched this, then thank you. However, the reason why I am recording this video is because of the problem H, which I was unable to solve during the contest. Well, I solved it, but wasn't able to get accepted. So this is my solution. Well, I think I need to explain the problem. Let me think how best do it. So basically, in this problem, we have n people on a line. The position of the ith person is xi, and the person number one has a football, and they need to pass it to the footballer number n. Each person has the maximum speed of a kick, and they can kick a football with this speed. And the aim is to pass the ball to the nth person in minimum possible time. However, it's not allowed to make more than k changes of direction. So the ball changes its direction if it moves to the left, stops at some person, then moves to the right, or vice versa. This means that the ball changed direction. The number of changes should be at most k. So this is the formulation, and to solve that, firstly, if we forget about k, then it is a simple convex hull trick problem. So if we have some footballer and he passes the ball somewhere, then the time it takes to get the football to some point is a linear function. And if you want to move the ball to some point in minimum time, you need the minimum of these linear functions. And this can be maintained by convex hull trick. Actually, we need two convex hull tricks, one for the left part, to the left of the first footballer, and one to the right of the first footballer. So that's basically it. We have two convex hull tricks. Unfortunately, though, it does not keep track of changes of direction, and basically you can just add a new dimension to your dynamic programming, which is the number of kicks, with the number of changes of direction. However, this is not good because it it's just kinda slow. Well, it's slow because we have 300,000 persons. So times log n because of convex hull trick, and if you also multiply by k, this becomes too slow. However, instead of that, you can use something called lambda optimization. You say that you allow as many passes as you want, and each pass costs some fine called lambda. And if lambda is 0, then you basically have no restriction at all. However, if lambda equals plus infinity, then there is a restriction that you just never want to change the direction of the ball. So k basically is at most 0. And then, actually, if you run a binary search, then there is a moment when the optimal number of passes is exactly k, or exactly the best number that you can hope for. Therefore, you calculate with binary search this number, and thus get the answer. So I wrote it, and the binary search for lambda is somewhere here. However, still we got a problem. That it gives some inadequate answers. And that happens, I think, because I somewhere don't add lambda where I should. Well, first of all, I'd like to say that the actual answer on the samples is same. Yeah, so we have 7, 1. And if we add a sample where this is 0, then the actual answer should be 9, and it indeed equals 9 after that. However, it's still getting a wrong answer, and moreover, it gives some negative answer here. I can't open it. Wow, I cannot open it. Okay, this is strange that I cannot open it. The best way to find such strange behavior is to write a stress, so that's what I'll do now. Stress is kind of standard function, however, it always takes quite some time. So what do you need in stress? You need several things. Basically, it's just a infinite cycle where you are looking for. So first of all, you're trying to create a test. Then you feed it to two solutions, your solution and the fast solution. So the test consists of two vectors and a number. Basically, that's it. Actually, we can already generate a test. So let's say test.text.resize n, test.test.resize n. And we basically said test.xi is UID from 1 to C. And the same for S. Finally, test.k is UID from 0 to n and return test. Well, after that, so we have generated the test. Then we need to find a past answer. And slow but correct answer. And if they are different, then we print in this form the test. Yes, and return. So now we only need this function, find slow answer. So how do we do it? Basically, we need to find the number, to find the fastest way for the ball to get to each of the footballers. So how do we do that? Basically, yeah, basically we say val ans of size n, and initially it is infinity. But ans 0 is 0. Then we can make at most k plus 1 passes. So during a pass, we either move the ball to the right or to the left. Let's make old ans. So what do? We say ans.swap. Actually, we can just say old ans equals ans, and then we need to move the ball to the right. Yeah, so what do? Oh, let me think actually. I either try to move it to the right or to the left. Yeah, I get it. So we simply say that. So we try to do it in quadratic time. So let's try to move the ball from ith person to the jth person. Actually, for that, I want the balls to be sorted. Okay, let's sort the balls. Okay, so in the order, I'm trying to pass the ball from order I to order J. How do I do it? I say that answer order J is minimum of answer order J and answer order I plus x order J minus x order I times the speed of order I, inverse speed. And the same thing from, actually old ans, only old ans. And the same thing from right to left. Well, that's basically it. In the end, we say that return answer of n minus 1. Something broke. This was the slow answer. Actually, I don't see a reason why it should work like this. Pos is 2? Where? Which pos is 2? Border is not 2. I is 2. Okay. Okay, it found something immediately. But this test is too big, so I'd like to have some small tests. 2, 2. Let's start with the smallest possible, 2, 2. Okay, you see, it cannot find. And even if I put here 20, it cannot find. Yeah, but if I put 3, maybe it finds something. No, still no. 4. It does not find anything for 4. But if I put 10 and 10, it finds a test of size 4. What's happening? Ah, I see. I see, I just needed to put home here. Okay. So let's try again. Let's put 2 and 2. Okay, it didn't find the test. What about 3 and 20? Okay, this file found something. So it says that 3, 0, 5, 7, 11, 13, 2, and 6. Let's make this smaller for me to understand something. Maybe even 2 works. Maybe even 1 works. No, unfortunately 1 does not work. Okay, 1, 1, 2, 2, 1, 1. Let's look at this. Take a look at this test. Stress is commented. So it is 1. This test says it is 1. However, I see. I think we need to make ans 0, 0 for all footballers who are in same point as 0. So if xi equals x0, then ans I equals 0. Then it shouldn't fail this time. It says 1. But now I think the stress will also agree that this is 1. Yes, the stress agrees that this is 1. Let's go on. Again 20. Okay, if we have 20, it finds something. Okay, 3 0 1 2 3 3 2 3. Let's look at the correct answer. And at the fast answer. So in this test, correct is 6, but the fast is 5. How is correct 6? So we pass our ball to the second person in 3 seconds, and then the second passes the ball to the third person in 5 seconds. In 2 seconds. No, it should be correct. It should be correct. Why isn't it correct? Okay, let's see somehow, because it's strange. Ah, so I need to make like ans left and ans right. So let's make them left ans and right ans. So here I already have the correct answer. Then here I say that left ans is answer and right answer is answer. Then here I optimize the left answer, and here I optimize the right answer. And then I say that answer I is minimum of answer I, minimum of left answer I, and right answer I. It's still incorrect. It still says that the answer is 6. Why are you doing this? Ah, because I need to put here left answer maybe. Okay, now at least this is better. So we can back change it to 13. Okay, it again finds something. not for 4. Not for, for 5. Okay. So 2, 1, 5, 5 to 1, correct 15, fast 13. Why? We are in point 2. We can pass to this footballer in 15 time, but we can go to the left. 5 plus 8. Yes, it is incorrect. The answer shouldn't be 3. The answer shouldn't be this big. Okay, this is definitely an incorrect test. So we want to get 15. We want to get 15. Okay, let's go. Okay, let's write like this, and answer is greater than this. Okay, for some reason it's now 14, and even after that it's 13. Let's look into this function. Okay, for some reason this is 13.0. However, it's not correct. Maybe because we need to have +1 here. Yeah, I think we need to have +1 here. And now it magically becomes 15. Now we magically can continue our stress. Okay, now it does not find the test so easily. Maybe if we put 15 here, 50 here. But no. What about 10? Okay, it found something. What about 4? Even for 4. What about 4 here? What about 2 here? and 3. Okay. So correct is 1, but fast is 3. For some reason, it cannot find the answer 1, which should be here. Let's see. Let's see what prevents us from finding this answer. Okay, I have a pretty easy test. So ST is 1. ST is 1, and I can pretty easily just pass from... Why S is 3? So S should not be 3. This is the error. Why does it look so strange? Because this should be moved down. Yeah, this is a sneaky bug. It should be like this. And like this. And like this. And like this. And like this. Or not. Ah, yes. Then I need to... Why does it keep moving? Stupid Visual Studio. Okay, now it finds the answer 1. And we can again continue the binary search. Oh, not by the binary search, but the test search. Okay, now it is unable to find such a small test. But what if we replace it with 30? No. What about 10? Yes, it finds something. However, the test should be sufficiently big. So it cannot find anything for 5, for 6. Ah, it found something, yeah. There is a test. Can I make it smaller? Okay, it found something even with 5 of them. But not with 4, definitely not with 4. Correct? Am I correct? So for 4, my solution is fine. No. Even so. Okay, let's check at least 3. Yes, we need at least 4. So the tests on which this doesn't work are pretty rare, but still they happen. It's funny that it's found the test with 24 pretty fast, but now it cannot find the test which is smaller. Okay, so the correct answer here is 166, but I find 169. I think we need to examine this. Yeah, I think we need to examine this test. So, what do we have here? We have here 4 persons. 16, 15, 24, and 1. And we want to send the ball here. Okay, I see. Actually, maybe the fastest way is to go like this, then like this, and then like this. And the answer will be 15 plus 9 times 11 plus 2 times 23, which is equal to 160. However, we can do it. Instead, we can send it to the right and then to the left. And it will take 8 times 15 plus 23 times 2, which is equal to 146. Yes, yeah, you can see it. However, 166. However, for some reason, my solution says 169, which is definitely incorrect. I can't even imagine. 169, maybe if I send it directly to this point, but it's still not that answer. It will be 15 times 15, which is... it says directly, so maybe it's 15 times 1 plus 11 times 15 equals 11 times 14, which equals 154 plus 15 equals 169. So for some reason, it is trying to send it directly. Let's see. Okay, in this small example, we have only x equals minus 18. Well, this is definitely not good. Okay, what happened? For some reason we only have... What is this test? Ah, this is because I have a stress. I see. Okay, here I have minus 24, minus 16, minus 15. The target is minus 1. ST is... I need debug here. ST is 1, lambda is huge. Ah, we have a problem. So actually I'm trying to find the answer with exactly that. I don't understand what to do. Ah, can I physically make the answer at least k? Well, maybe this is not solved with lambda optimization. I'm not sure if this can be solved with lambda optimization. So in this problem, k is at most n, but it should not be exactly n. It can be at most n. Okay, I really don't know how it works, but let's try something. So first of all, in this sorted version, let's say that lambda high is this number divided by k plus 1. Okay, secondly, let's say that if answer dot y is less than k, and we will pass also k, then answer dot x plus equals lambda times k minus answer dot y, and ans.y equals k. And here we just pass k. Maybe it helps, I don't know. No, it does not find the answer 166, which is correct here. But why? Why is that? Okay, how does it look like? I guess we can write so a graph. So for each k, exact k, we can find the optimal answer. Or the other way, yeah, maybe like this. Yeah, and when we say that each k costs some number, this means that we simply find some. We simply take some. Some tangent. It does not. Actually, it does not find. First of all, we can just try to send it, I think. Yeah, it is. I think we will get WA, but maybe it gets accepted. It's funny. The fact that I have anti-test doesn't necessarily mean that they have anti-test. Yeah, they have something. Okay, how does it look like? So we have something like this. And it is stopped somewhere. Well, I don't understand what happened. What happened on this test? Well, in the end, it found some lambdas. Lambda low is 4 and lambda high is 5. But lambda low gives an answer which is too big, I think. Okay, let's look at the case lambda equals 4. Okay, currents 168 and 2. 168 and 2. So it's better to go to the right and then to the left. What? Okay, so for 0, when we don't want anything, we say that the answer is we just go to the left and it becomes 169. And then for 1, the optimal answer is to the right and then to the left. And it is equal to 166. Then the optimal answer is go to the left and to the right and to the left. And it is equal to 160. Yes, it looks, unfortunately, it looks like not a convex function. It's like convex in the wrong way. Well, that's basically extremely bad. The only idea that I have is that we might try to force some parity. So we might try to force to go to the left or try to force to go to the right. Because without that, I don't know. Okay, let's try and do it. So what do we say here? We say here that if I minus if I minus 1 is not equal to start, or if we are allowed to go left, then this. And here, if yi plus 1 is not equal to start or not LFT, then this. And then here I try to take minimum of true and false versions. I need to do it separately for truth and for false. Okay, now it's 166. And we can continue the stress. Okay, maybe the reason why it cannot find anything is that they're really just combination of two convex functions. The combination is not convex, but separately they are convex. Incredible. Well, it's not incredible. Maybe I cannot just find the test. So we need to try to submit it. But if it gets accepted, it's funny. Well, I don't know. Don't you think it's a bit hard? 28 submits. All these people tried Lambda, failed, found out that it's combination of two convex functions, and optimized them. Are you kidding me? This is dubious. I don't know. Well, it was some fun, so thank you for watching.